on solving using square roots, but to solve using square roots, you need perfect squares, okay? Oh, sorry, I don't know. It's at the wrong page. Oh, no, it's just at the bottom of that page. Okay. So if we want to solve using square roots, we need perfect squares. So when you look at example 1, A and B could both be solved using square roots, because notice how X is in each of these problems. That X is all right here contained inside the square, and you don't have another X anywhere else. That tells you that square roots could be a way for us to solve. So if I wanted to solve part B right here, I would add 3 to both sides. And then divide by 8. So I'd have that x squared is equal to 4. And this is the point where I'd want a square root. So in order to know when you want to be able to use square roots, we want to look for, like, is everything I'm trying to solve for in a perfect square? If there was other x's in this problem, I couldn't just start square rooting stuff. It wouldn't work well. The second is when you actually do the square rooting, so you've gotten the squared alone and you do the square rooting, you have to remember the types of answers you could have. So that said x squared equals 4. What number squared equals 4? 2 or negative 2. So this is why you guys kind of had that like rule that you might have made up in Algebra 1 that says every time you square root both sides of an equation, we want to include plus or minus. Really, it's not like some random rule that somebody made up. It's saying if something squared turns out to be a certain number, you don't know what it was before it was squared. You don't know if it was a positive or a negative, because squaring both of those things turns into a positive, okay? So is everybody okay with solving something like this using square roots? Okay, so our goal is to make everything look like this today. All right, so we're actually going to skip example 2. We're going to move on to example 3. And example 3 does not look like that, okay? Why wouldn't I want to just start square rooting stuff here? Yeah, there's a b value. There's a 12x. Even if you move everything away from x squared and you go to square root, you're going to have an x underneath the square root, but you're supposed to be solving for x. It's going to be very confusing. So your options here are to solve by factoring quadratic formula or to make things a perfect square. Now, this one is actually set up very specifically that this is already a perfect square. Okay. If you factor this, it is x plus 6 squared. Now, normally I would not factor something and have it set equal to 9, because do we really want to set things equal to 9? Like if we know 2 things multiply to make 9, do we really know anything about those numbers? No. We only want to do it with 0 because of that 0 product property. If 2 things multiply to make 0, definitely one of them is 0. We normally don't want to factor if it's set equal to 9. The only reason I did it here is because I recognize that as a perfect square. You guys had a problem like this on your last weekly review. I think it was x plus 3 in the parentheses, maybe not x plus 6, but something like this. And about half of you guys got it right, but half of you got it wrong, not because you didn't know what to do here, but because you didn't acknowledge that plus or minus piece of it. So people that did take the square root, here, the square root of 9 is not just 3 in this case. I want to consider both positive or negative 3 because I don't know which of these numbers was squared to make 9, because either one could be squared to make 9. So this is actually 2 things to solve. The stuff in the parentheses could be equal to positive 3, or the stuff in the parentheses could be equal to negative 3. And so this gives me 2 different solutions. Okay. So the purpose of completing the square, I know you guys have done it before. How many of you really like completing the square? Like you have great memories of completing the square. Oh, look at you now. Good. Oh gosh, and Morgan. Okay, good. How many of you do not like completing the square? all right, then you guys will really like quadratic formula. But here's the thing, we do have to know how to do it. And it's actually more than this. You could probably get around most of our quadratic stuff without completing the square, because there's so many things you learn about a quadratic that you can kind of like use other methods to get what you need. However, we are going to learn circles later, and in pre-calc you're going to do like ellipses and stuff. And if you remember the equation of a circle from geometry, it looked like this. So the equation of a circle is literally made up of perfect square plus another perfect square. So in order to get it in this format, guess what you have to do? You have to be able to make perfect squares. The process we use to make perfect squares, completing the square, right? Makes perfect squares. So I know it might not be your favorite, and you're going to have some other options, but we have to at least know how to do it. Sometimes it's not too bad, and sometimes it's more difficult, okay? So now we're going to actually look at completing the square. And so completing the square is saying I'm going to put in a value that makes it so this quadratic is a perfect square. Does that make sense to everybody? So like in the last problem I said this one's really nice, the x squared plus 12x plus 36. Like I wrote it so that it factored perfectly as x plus 6 squared. When you complete the square, you're deciding what this constant should be in a problem in order to make it factor as a perfect square. That is literally the entire purpose of completing the square, so that you can solve by taking square roots, and you cannot do that unless you make a perfect square. Is that okay with everyone? All right, so first problem. How would I make a constant here that makes a perfect square? So think about factoring, and then we'll kind of develop a formula. I know some of you already know. If we were factoring and we wanted to get two of the exact same thing, the beginnings would have to be x, right, to make x squared. And how would we make 18x in the middle if we want our two factors to be exactly the same thing? So that 18x in the middle is made up of two things added together, right? When you FOIL like this and this, 9. So we would want a 9 and a 9 so that we'd make a 9x and another 9x, and they would add up to 18x. Is that okay with everybody? So if we wanted this to factor as a perfect square, we would want these to be x plus 9s. So what is the c value in the expression that I've written up here if we know that the 9s are what we would need to make two of the exact same thing with 18 as the middle term of that polynomial? Andrew? 81. Are you guys on board with where he's getting 81? Like if this is how I'm going to make 18 with the same two things, those last terms multiplied together are going to be 81. Okay. All right, now with some things it's not as nice to figure out the numbers. 18 was a nice and easy number to deal with. So we kind of want to make a little like formula for ourselves about how this worked. So we based this idea around the 18, right? The 18 in our equation is the b value. So this idea is based around the b. What did we do to the 18 to get 9? Divide it by 2. That gave us the 9s. And then how did we get that 81 was the number at the end here? The 9s that we made did what? Squared them. They multiplied themselves, which is like squaring them, right? So this guy right here is kind of my shortcut to not have to do this thinking every time. That every time something is set up like this, I can take the b value, divide it by 2 and square it, and that will tell me what should go as that constant to make a perfect square. Is that okay with everyone? So if I were going to do it in the next equation, part b here, the b value is -9. I'm going to divide that by 2 and square it. And piece of advice, if we're doing things by hand without a calculator, leave it in fraction form. And I'll show you why in a second. I know fractions aren't your favorite, but they're going to work out a lot better when we're solving this way than if you start turning things into decimals and you don't have a calculator, okay? So -9 over 2 squared is 81 over 4. So you might not like the way that looks. And if you're like, I don't even get it, Miss Dahl, like, how did this make a perfect square? think about it. Now, our answer to this problem is 81 over 4. We're done. But we need to build some connections. So you just figured out this c was 81 over 4. Remember, the whole purpose in completing the square is that this should now factor as a perfect square, 2 of the exact same thing, which means the first term would have to be r, or x, yeah, but in this case r. And then what would be squared at the end? What would have been multiplying times itself to make 81 over 4? 9 over 2. Do you see how it's nice to keep it as a fraction even though you don't normally like fractions? 81 over 4 not as a fraction is like 20.25. I'm not saying you guys aren't capable of figuring out what made 20.25. I'm just saying that like it was a lot easier for us to look at this and be like, oh, 9 over 2 times 9 over 2 would have made 81 over 4. Then like what times itself makes 20.25? Like I don't know. So I think if we're not working with a calculator here, oops, it would be best to stick with fractions. And then should it be minus or plus 9 over 2? Yeah, it should be minus. Good job, those of you that are saying it. Do you guys know how they're picking that out? Remember, when you multiply this back out, we're not going to, but we knew it was r times r to make the r squared, and we knew it was 9 over 2 times 9 over 2 to make the 81 over 4. But the middle term is made by r multiplying this, and this other one multiplying r. And if those two things are going to add together to make this middle term right here, they would have had to have been negative. Is that okay with everybody? All right, so all this bottom part was unnecessary. I'm just trying to build for you the understanding of like how that number then works to make a perfect square for you. Okay? All right, what is more difficult about part C? Yeah, come on. Good. This little formula that you guys came up with only works when the beginning thing just says like x squared or r squared. We totally don't have any idea what to do when it has a 2. So if it has a 2, you're literally forced to take the 2 out for a little bit and look at it without the 2 in order to complete the square. So does everybody understand you cannot do b over 2 squared if it's not set up like this with a lead coefficient of 1? This little formula you came up with only worked in this instance right here. Do you want to come up with a million different formulas in a million different instances? No. So how we're going to deal with that is every time there is a number here, we're just going to take it out temporarily, okay? Or maybe permanently, depending on what we want to do with it later. And then we're going to make it look how we're used to making it look and do our b over 2 squared, okay? And now when we do b over 2 squared, this is the exact same problem that we just did, right? So what are we going to get as our constant here at the end? We just did, when the middle term was -9, we just did it over in this problem here. So we get 81 over 4. Now, is that the answer for C in this problem? No, because C is the constant that's there when the 2 is in front of the r squared, right? So what should we do to be able to see what C is? Emily? Yeah, now let's just like put the 2 back in and it will look how we want it to look, right? So this is 2r squared minus 18r. And then what do we really have there? We have 2 times 81 over 4, which is really 81 over 2. So this is my C value. Is that okay with everybody? So one of the main things here besides knowing how to complete the square is that you really can only use this in a specific instance. So you're going to have to deal with this every time in the same manner. Does everybody feel like they can just complete the square? Now we can see what we can actually do with completing the square, okay? All right, so why we want to complete the square. Sometimes to solve things, sometimes to rewrite things. And this is where you can get away with maybe not knowing it as well right now, but it'll come back to like haunt you a little bit later with things like those circle equations. There's no way around it. But here, when you guys look at these things that we're about to solve using completing the square, and we're going to do completing the square because the directions say, on your quadratic test, I will not say solve by this. I will just say solve. So the downside to that is I'm not going to tell you what to do. The upside is you get to choose what to do. And if you hate completing the square and I just ask you to solve, then you never have to complete the square, okay? Unless I ask you like what constant would go here to complete the square, but I will never direct you how to solve. In your homework, you will constantly be directed how to solve. And there, I would like you to follow the directions. By the time we get to the unit test, I totally believe you can make your own decision. Like, I've seen all the ways to solve. I like this way better. This one's more convenient when it's like this. But until we are there, I would like you to get as proficient as possible in each of the ways so that you're able to kind of be more versatile. Like, everyone who just uses the quadratic formula, like if something's factorable and you're using the quadratic formula, you're probably taking a lot of extra time to like figure out the quadratic formula. So instead of relying on one, we want you to be able to like use each tool, but use it where it's like fastest or most efficient for you. So just be aware, your homework will tell you what to do. On your test, I will not tell you what to do, okay? But you can do whichever method you want. Does that make sense to everybody as far as expectations, so it's real clear? Okay. All right, so let's say we go to solve by completing the square. And let me see how much. Okay. All right, so the first one here, which is totally factorable, by the way. If I was not told to complete the square, I would 100% factor. But I am pretty fast at factoring, so I like it, and it's quick. So when you go to complete the square, that means you're basically looking to turn whatever's here into something squared so that you can solve by taking the square roots, okay? So when I look at what's here, is 120 a perfect square? No. Is 120 a number that has a perfect square root? No. So that is definitely not the number that I want there to make a perfect square. So the first thing I'm going to do, which is a little different than factoring and quadratic formula, because in factoring and quadratic formula, we want things set equal to 0. With completing the square, it doesn't matter. I'm moving the 120 over to make room for something that I'm going to choose to put into the equation specifically to make it a perfect square. Okay? So now I'm going to do what we did above. I'm going to figure out what number should be there if I want it to be a perfect square. Okay? So what number should I put here if I want this to be a perfect square? What's that? 1. Do you guys agree with her? How is she getting 1? Sorry, she's using the little formula, right? So she's taking the middle term of 2, she's dividing it by 2, and then squaring it. So 2 divided by 2 is 1, and 1 squared is still 1, so I want to add 1. Now I've totally changed the problem. This is not the problem that was given to me. I put a new number in it. But this is an equation, so I can put a new number on the left side of the equation as long as I do what? Balance it out and put it in on the right. So I'm going to add the same amount to the right side. And then a lot of people get stuck with like, what do I do next after I complete the square? What have I been saying over and over again today? What is the one purpose of us completing the square? Why are we doing this? What are we trying to make? Perfect squares. So the thing I should do after I complete the square is write it as a perfect square. That is the entire reason I am completing the square. That should always automatically be my next step. Otherwise, there's no reason for me to be doing this. Okay? It's the only purpose. So this factors as x plus 1 squared. And on the right side of the equation, I would get 121. And now that everything is in perfect squares, all of my x's are inside of the perfect square, I'm going to go ahead and square root. So I get x plus 1 on this side, and on this side I get 11, but I can't forget that it could be positive or negative 11. So remember that this is giving us 2 options. Okay. So we can get 10 or negative 12. Is this all right with everybody? So we use completing the square to make perfect squares. When do we want to make perfect squares? Either to solve something or to rewrite something, which we'll see in a minute. All right, so we're also going to do part B. And part B is just going to be a little bit more of a pain in the butt, okay? So like if I had choice right now, if I'm taking the test and someone gives me this on the test, I'm going to be perfectly honest with you, I would not choose to solve this by completing the square. I can do it, and I can get it right, okay? I would probably just go use quadratic formula if it's not factorable. I like to try factoring, and then I usually move on to quadratic formula. If something like A wasn't factorable, I don't mind completing the square in part A. Do you guys see why? It was like pretty, like just move the one thing out of the way and it's very easy. What's gonna make part B, what makes me say, even though I'm gonna do it right now, that if I had choice, I would not solve this one by completing the square? Does anybody see the difficulties why I think this is gonna be kind of a long drawn out process? Stefan?
The A value.
Okay, yeah, so first of all, there's an A value. Morgan? Yeah, and the B value is an odd number. So I have like an A value, which I'm going to have to factor out. I have something not divisible by 2 in the middle. Do you see kind of the hurdles that we're going to have to face using this here? Now, we're still going to practice this like this because we have to be efficient at doing this in any situation for later things to rewrite them. But in the context of being given choice of how to solve, just as you're learning it, still be cognizant of why it's good in this situation or also why it's not so great, okay? So what do you guys want to do first, given the hurdles that we just saw? Get rid of the 2. I can't even complete the square if the 2 is there. What are my options for getting rid of the 2 in this case? Emily? Good. I can factor it out like we saw before, but in this case, I can actually just get rid of it completely and divide everything by 2 because I have an equation, right? So I can choose to divide this side by 2 as long as I also divide this side by 2. I'm going to have this great equation now. Look at that B value. It's looking great. All right, what do I want to do now? Susan? Good. 6 is not a perfect square, and it's not related to 7 over 2 at all. It's not the thing I want if I'm trying to make a perfect square. So I want to move the 6 to the other side since it's not going to help me make my perfect square. And now I need to make the perfect square. How do I make the perfect square? B over 2 squared. And look at the B value. Okay. So the B value is negative 7 over 2. And what do I want to do to that? Divide it by 2. Are you guys okay if I write that as times a half? Because I already have a fraction, and a fraction over a fraction gets a little bit confusing. I'm going to do that, and then I'm going to square it. So that's negative 7 over 4. When I divide negative 7 over 2 divided by 2, I get negative 7 over 4. And I need to square that, which gives me 49 over 16. Okay. And you might hate this and be like, Ms. Dahl, please just let me turn it into a decimal. Like, I don't even know what 49 over 16 is as a decimal, so I'm just going to be patient with myself. And 49 over 16 might look horrendous, but guess what? 49 is a perfect square, 16 is a perfect square, so it's probably going to work out okay, all right? So be patient with the fractions. So that's the special number that I want here, even if I really don't like it. And I want to add the same amount to the other side because I've just changed the equation, and I want to make sure I'm not technically changing the equation. All right, you do all this, you feel all proud of yourself, right? You get the number on the paper. What was the purpose of figuring out that 49 over 16? To complete the square, which means what should my next step be? Why do we complete the square? Anthony? Good, so we can actually make something that's squared. So the next step after completing the square should always look like this. Okay? And what are the factors going to look like in this case? 2 are the same, that's why I have the squared. What's the first term of the factor going to be? X. What's the last term of the factor going to be? What times itself would make 49 over 16? 7 over 4. And should it be a minus or a plus in the middle? Minus, and that's because when it gets multiplied out, the middle term becomes negative. Okay. So this is going to actually be the worst part right here, is that I have to actually add negative 6 with 49 over 16. So I'm going to put a 1 in the denominator for 6, and then I'm going to multiply that by 16. And 6 times 16, 36 is 96. So they have a denominator of 16. And negative 96 plus 49 is negative 47. And now what do I do? What was the purpose? So if I just ask myself the purpose of the previous step, I can probably get to the next step. Like, why did I complete the square? To make a perfect square. So write it as a perfect square. Why am I writing things in perfect squares? So I can do what? Yeah, square root it. So what should I do? Square root it, okay? So on this side, we'd get x minus 7 over 4. On this side, we get plus or minus, and luckily the square root of 16 is 4. See how that works out pretty nice? Unfortunately, or maybe you'll think fortunately. So if this didn't have a negative underneath the radical, the last thing we would do is add the 7 over 4 over, and you would just have like a weird answer. It'd look very quadratic formula-ish. You'd have 7 over 4 plus or minus this radical over 4, okay? Or you could write it as 7 plus or minus the radical all over 4, okay? So just to show you guys what that would look like, I see some people looking at me like, yeah, I don't really know what you're talking about, okay? That x would equal this, which can also be written like this, okay? And then you would try to simplify the radical. But what's the matter with everything that I just did here? What's like, whoa, 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 like alarms going off in your head, Vanessa? Okay, so we'll actually learn on Monday that we can square root a negative in a different realm of numbers. So we're going to learn an additional part of our number system that you've never been told about before, or maybe you have, called imaginary numbers. But they're real, but they're imaginary. But we use them, but they're imaginary. Okay? All right. But for right now, if you got this answer, you would stop and say no real solutions. We'll work on how to write it if there aren't any real solutions, which means like you won't see it cross the x-axis on the graph because there's not a real number that it hits, but there's an imaginary number. Okay, we'll talk about what that is, all right? I know, a little outside the scope. So for this right now, we'd say has no solutions or no real solutions, and we'll work on how we would write this next week using some different number systems attached to ours, okay? So no solution is okay for now, all right? And you can make a little arrow to the negative underneath the radical. If that negative wasn't there, this would totally be our answer, right? It's not like super friendly looking, but totally looks like something that come from the quadratic formula. So we're basically doing the same kind of stuff, okay? All right, last thing that we're going to do is use completing the square to rewrite something instead of solve something, okay? And you guys are going to have a little project of the week in this unit too. We're going to do it next week, kind of midweek, because next week you guys have the PSAT and we have like a great shakeout drill. So given that we have like those 2 days with like special things going on, our schedule doesn't technically change, but those things will kind of like not give us tutorial time, or a bunch of you will be gone for the PSAT, right? We're going to do a project of the week, but it just involves practicing all of this stuff that we're doing here, okay? So you'll have time in class to work. Like it'll be kind of 2 days where we're just focusing on that. And so if you're not here, you know what we're focusing on. And if you are here, you get class time to just do it, okay? So one of those things that you're going to be working on is you're going to be given a quadratic equation and you're going to do everything with it. So you're going to like graph it. It's going to be given to you in standard form. We want to see if you can write it in factored form and in vertex form. We want to see if you can tell us all the characteristics about it. We want to see if you can solve it by completing the square, as well as quadratic formula and factoring. So we're kind of like, can you do everything with a quadratic? You won't do all those things all the time with every quadratic, but we just want to make sure that you have this like whole little toolbox of skills so that you can do whatever you need to at any point in time with the quadratic, okay? So one of the things we want to be able to do is rewrite it in vertex form. So I'm actually just going to focus on part B here, because it's a harder equation given that it has that 2 in front and we're trying to rewrite it. So vertex form for us looks like what? Of a quadratic, what did we say vertex form looks like? So it has a and then what? X minus h squared and then plus k. So the special thing about vertex form is it has all the x's wrapped up in a perfect square, which means if I want something to be in vertex form instead of standard form, I need to make a perfect square, okay? How do I make a perfect square? Completing the square, okay? So This equation is very similar to what we just worked on. There's a 2 here, but now our equation is not set equal to 0 because we're not solving. So dividing both sides by 2 here, I mean, you can do it, but then instead of having y on the one side, you would have y over 2, which is kind of weird. So what's another way we can not have the 2 in there, but we're not dividing by 2? Technically, we are, but we aren't. What's that? Good. Let's just like factor it out. Is that okay with everybody? All right. So we're going to factor out the 2. The other thing is the 10 the thing we want to be part of our perfect square? No. So here's what I'm going to tell you guys to do. Notice the setup here. We want the perfect square, and then there can be numbers outside of the perfect square. The 10 is something that we don't even want to include in our perfect square. So I'm going to focus on these things plus something extra to make my perfect square. And the 10 is going to be honestly the starting to like the k value. I'm kind of kicking him out of the quantity I'm looking at. Like, you just go wait over there. Okay, so I'm going to think about these two things being grouped together, the 2x squared plus 7x, and the 10 kind of being outside of that. So when I factor out the 2, I'm actually not going to factor it out of the 10 because I'm going to leave the 10 outside of the parentheses because I already knew it's not anything I want to help me build my perfect square. Is that okay? So the first thing I did was I really focused on this being the group that's going to build the x minus h squared, and that the 10 is going to start building the k position. The reason I decided it should do that is because 10 is not my perfect square number, right? If it's not my perfect square number, it can't be part of the perfect square, which means the only other place for it is in that position with k. Does that make sense? So if it's not part of your perfect square, it needs to be thought of as kind of separate, even though it's on the same side of the equation. Everything with the x's in it is going to have to help you build your perfect square. And then like you guys said, we can't really keep a 2 coefficient. So out of these 2 terms here, I factored out the 2. And then I left myself a little bit of space because I know I'm going to want to put a number in there that does make a perfect square. Is that okay with everybody what I did? Why the 10 didn't have the 2 factored out of it, that I don't want it as part of this group right here. Okay? All right, we already did the completing the square for this one in the last example. What should be the c value that we add in here if the middle term is 7 over 2? What was it? 49 over 16, is that right? Let's look back. Yeah, 49 over 16 was the thing that got added in. Are you guys okay if I just use that instead of going back through that process again? Okay. So 49 over 16 is what I want to add in here. All right, so I just completed the square. Why do I complete the square? To make a perfect square. So what is the next step that I should do in my problem? Write it as a perfect square, right? So I want this as a perfect square. Oh, but I forgot something. Does anybody know what I did? I mean, I'm not wrong. I do want to write it as a perfect square. Emily? So I don't have to move the 10 over to the other side. I can keep it here because the other side has y on it right now instead of 0. I can keep it here, but I made a change in the equation.
I think you have to add 49 over 16.
Good. So like I put something new in the equation and I never like balanced it out. Is that okay with everybody? Okay, how much did I really put into the equation? My pen wrote down 49 over 16, but that number has some other things going on with it. What is that number really worth? What's that? Not 7 over 4. That's if we rewrite it as a square, which we will in a minute. What operation is happening to 49 over 16? It's in a group, and what's happening to the group that it's in? The group that it's in is being multiplied by 2. Okay? Oh, now I'm on this. So I cannot say that it's really 49 over 16. I wrote 49 over 16, but that number is really 49 over 16 being multiplied by 2. So if you have to, go off to the other side. What is 49 over 16 being multiplied by 2? And that ends up being 49 over 8. So though my pencil wrote down 49 over 16, because it's being multiplied by 2, the amount extra that I put into the equation was really 49 over 8. Is that okay with everybody? I need to balance that out. How do I balance out the fact that I inserted 49 over 8 extra units onto the right side of the equation? How do you fix that? If you add 6 to one side of the equation, what do you have to do? Add it to the other side. So if I added 49 over 8 extra units to the right side of the equation, I need to add it to the left. Now, you have two options. You can add it to the left, or you could do what? What if you don't want to put anything on the left because you want to just keep your cute little y equals over there how it's supposed to be? Yeah, so adding to the left is the same thing as subtracting from the right. So let me show you guys like this. Let's say you had y equals some stuff over here and you decided to add 4. And so you say, well, you should also add 4 to the other side. If I don't want that 4 on the left side, what do I then do? Subtract it in order to bring it over here. So you can add it to the left side because you added it to the right side and move it over later. Or you can say, I added 49 over 8 to the right side, so I'm also going to subtract 49 over 8 from the right side. I've literally put 0 on the right side now. Does that make sense to everybody? I added an amount and I subtracted the same amount, so I've technically added nothing to the equation, but my pencil wrote down lots of stuff. Is that okay? All right. All right, so now get to the writing in the perfect square part, okay? Our perfect square, x will be the first term, and because of the 49 over 16, like Morgan pointed out earlier, 7 over 4 will be the second term. Should they be added or subtracted in this perfect square? Added, right, because of this plus. So I now have my a and my h, and I'll have my k once I take the 10 that I put out there to be part of my k, and I combine it with the minus 49 over 8 that has to be there so that I didn't technically change the equation. So again, I'm going to want to change 10 to be more like 80 over 8. Okay. So 8's the denominator, and 80 minus 49 is 31. Okay. All right, so there's this beautiful vertex form of this equation. Look at that vertex. Negative 7 over 4, comma 31 over 8. That's fun to graph. Okay. And then why didn't we take square roots this time? I said we're taking perfect squares, take square roots. Why didn't we not do this in this problem, but we did in the previous example? Good. It just asked you for the vertex form. When we were taking square roots, what was it specifically that we were doing? Well, in each case, we completed the square. In this case, our ultimate goal was to write in vertex form, and vertex form has a perfect square in it, so we want to leave it there. What were we doing previously where we would write the perfect square and then square root it? Solving, okay? Our purpose was solving. It's really important you guys understand what you're doing in these problems because there's lots of stuff you could do. So it's important that you keep on track for like, what am I actually trying to do here? And that way you can figure out what's happening, okay? So is everybody okay with number 1? We know how to basically complete the square. Like the whole little b over 2 squared gives me the special number that I need. Okay? Do we understand that in every case where we were completing the square, the next step was to write it as a perfect square? That is literally the only purpose of doing that. Okay? And if we were rewriting, then we want to keep that perfect square in our equation. That was the purpose, just to see it in a different format. If we're solving, then we want to get that perfect square alone and start using square roots. Is that okay? Yes. All right, questions that you